Alright, in this video I'm going to be talking about solving radical equations and solving other equations that have maybe rational exponents or something like that. And so this is Unit 9, Lesson 2 in College Algebra. Okay, so first I'm just going to remind you of something that you knew in Algebra 2. When you square both sides of an equation, you need to do something. And you don't remember what it is? No, maybe kind of obscure. Okay, you need to check your answers. You absolutely have to, because you can get extraneous solutions. You can get solutions that you're working it out, you're doing all the algebra right, it appears to be an answer, but upon closer inspection, it is not a solution to the original equation. So we're going to need to check our answers. And the reason for this is pretty much this. So you've got two numbers like, say, 3 and -3, and they're not equal. Okay? 3 and -3, not equal numbers. But if I square both sides, I've got 9 and 9 are both equal. Okay? So you can start off with two things that are not equal, that end up apparently equal after squaring both sides of an equation or some sort of relation. Okay? It's a little more complicated than that, but I think that in doing some examples and seeing somewhere we're going to pull back some extraneous solutions, we'll see why that happens. All right, so let's just start with some pretty easy ones. So starting with the square root of x is 3. You could look at this and you could say, all right, I'm going to think of a number that if I put it into the square root of x, I'm going to get 3. And you might think 9. Okay, and you'd be right. But as far as like an algebra, do the same thing to both sides of the equation, or, maybe in Algebra 1 you talked about doing the inverse operation to solve for x. You think of what is the inverse operation of square root, that would be squaring. Okay, so I'm going to square both sides of the equation. So I got square root of x squared equals 3 squared. And if I square the square root of x, it's going to be x. And then this is 9. Now, since I did square both sides of the equation, I'm going to need to check my answer. Okay, you can just look at it and see, is the square root of 9 equal to 3? Yes, the square root of 9 is equal to 3. I'm happy. Okay, you can mentally check if you want, but I need you to check. Okay, and so I'll just write, I'm going to check, is the square root of 9 equal to 3? Yes, it is. Okay, I'm going to do it. That is a solution. Right, x to the 1/2 equals 4. Again, okay, maybe you just remember from last time that the 1/2 power is the square root, and you're thinking, okay, what number can I square root it and get positive 4? Well, it's probably going to be 16. But if you want to do the same thing to both sides of the equation, if you have an x to the 1/2 and you want to get rid of that, well, we want to get x to the first power. We want to solve for just x. So I'm going to need to multiply this by 2 over 1. So I'm going to need to take both sides to the 2 over 1 power, which is the same thing as squaring both sides. So when I get this, I am going to need to check my solution. Okay, this is just going to be x to the 2 over 2, which is just x to the 1 power. X equals 16. Since I squared both sides, I'm going to check, is 16 to the 1/2 equal to 4? Either you just remember the 1/2 power, that's the square root. Or maybe you grab a calculator and just run 16 to the 0.5 power and see what comes back. It's going to be 4. All right, so I would say y'all should try the ones on the right. These are third roots and 1/3 powers instead of square roots and 1/2 powers, but I think they're going to work pretty much the same. If you're watching at home, pause the video. The answer's about to come up. All right, there you go. So you think to yourself, well, what's the inverse operation of the third root? Well, the inverse operation of the cube root is to cube it. So I cube both sides of that equation. I get x equals 2 to the third, and that's 8. Okay, over on the right side, I've got the other ones. Why didn't I check these answers? Why didn't I check them? Well, what's different about this set of two problems than the ones above them? Yeah, it was the third root rather than the second. So I ended up cubing both sides rather than squaring both sides. Okay? You don't need to check your answers if you're taking both sides to an odd power. Okay? You're not going to end up with extraneous solutions. Okay, here we've got a few more. These are got a little extra layer of intrigue. And okay, the one on the left I'll do in terms of inverse operations, although it's not what I would recommend. Okay, and maybe I'll show you why. If you watched the last video, I recommend if you're going to take a number to a fraction power, like a number to a fraction power, you deal with the denominator first rather than the numerator. So on x squared, taking the third root of that, equals 9, what you would want to do first is to get rid of that third root, because it's kind of on the outside, and the inverse operation of third root is cubing. But the thing is, I don't know what 9 to the third is, and then I'm probably not going to know what the square root of that huge number is. So who knows, you know? And so it's 729. I don't know. Is it even 729? Who knows? Okay. What I recommend doing instead is turning it into a fraction power. So that's something y'all just did on the quiz. What power of x is this? Yeah, so well the cube root is 1/3, but if you have the squared on the inside, then it'll be 2/3. Yeah. Oh no. Equals 9. And now I'm going to undo that by taking x to the 2/3 to the 3/2 power. And then I'm going to take 9 to the 3/2. Okay. And then, of course, you can do 9 to the 3/2 on the calculator in this course, but you might come up against a time where you're not allowed to do that. So this is the 1/2 power is the square root of 9. The third power is I'm going to cube it. Okay, so and that's what x is. The square root of 9 is 3. 3 to the third is 27. Okay, x is 27. And you look, did I ever really square both sides? No, I kind of, if anything, square rooted both sides because I took the 3/2 power, right? So I don't need to check the solution. Okay. Here. And x to the 3/2 equals 27. Well, to get rid of that 3/2, I'm going to need to take both sides to the 2/3 power. Three halves times 2/3 is just 1 power of x. Okay, and remember, always deal with the denominator first. So 27 to the 1/3 is the third root of 27. That's looking like 3. And then I take that to the second power, and that gives me x equals 9. And this last one, maybe I'll have you try on your own. Okay, I'm going to freeze the screen. This one is not on your notes packet. I don't think. No, nobody sees that, do they? Okay, yeah, this is one I made up. Okay. Felt like y'all could use a little more practice on this. If you're watching at home, you definitely want to pause the video right now. All right, there it is. Again. All right, here we've got one where we need to, kind of isolate the radical first, and then, undo the radical's power somehow. All right, so now we remember from last time that when we squared a thing with a square root and a number, it was very unpleasant. So we're not just going to square both sides of the equation like that. That's not going to be our best course of action. What we want to do instead is isolate the square root and then square both sides. Bless you. So I'm going over here and I'm saying 2x minus 3. I'm going to add 5 to both sides, and then that'll be equal to 5. Okay. Now I'm going to square both sides. And as soon as I square both sides, I'm thinking to myself, I need to do what to my solutions? Okay, so I square both sides, and I'm going to need to check my solutions. And so this is 2x minus 3 is equal to 5 squared, which is 25. I'm going to add 3 to both sides, and that's 28. Divide by 2, and that's 14. Okay, over here on the right, I'm going to subtract 4 to get the radical by itself. That's 3x minus 12 cubed rooted equals negative 3. You might be thinking to yourself, oh no, this could be a problem. But it's okay for a cube root to come back negative. You take the third root of a negative number, it's going to come back negative. It's not a big deal. Okay, so I'm going to take both sides to the third power. And then I'll have 3x minus 12 is negative 3 all taken to the third, which is going to be negative 27. 3x minus 12 equals negative 27. Okay, you add the 12 back, and I think that's going to be, 3x is negative 15. That happens to be when x is negative 5. Okay, now this bottom one, instead of just setting y'all loose and seeing what happens, oh no, see, I made that whole, with ranting and raving about checking the solution on the first one, and I didn't even think to do it. Okay, so you got to go over here, you got to check the answer. All right, so you double 14, that's 28 minus 3 is 25. Okay, so is the square root of 25 minus 5 equal to 0? Yes, it is. Okay, I'm happy. 14 is a solution. All right, this is going to be one where when we go back and check, it's going to come back that it was not a solution. All right, so I need to isolate isolate the radical. So I'm going to subtract 5 from both sides. And I'll have the square root of 2 plus x is 3 minus 5. I'm going to square both sides. And I get 2 plus x equals 4. I subtract 2, and I get x equals 2. Yes, this one is not on your notes packet. This one is just like, I think it's about time for us to run into one with an extraneous solution and see where that all kind of comes from. So I just... All right. Now I've got x equals 2, but I squared both sides of the equation, so I need to check. So you go to check, and you plug in x equals 2 on the original equation. It's so important that you do this on the original equation, not on one that you've manipulated, because if you do it after you square both sides, it's going to look like it was the right answer. It was a solution. In fact, it wasn't. So I've got 5 plus the square root of 2 plus 2 equals 3. Well, that's like saying 5 plus 2 is 3, and it's not. Okay, so this is, an extraneous solution. We kind of strike through that one. So this equation has no solution. Okay, but there was a place earlier in here where I could see already that this was going to have no solution. Anybody see where it was? Yeah, here on that first red line, where I'm seeing a square root equaling a negative number. That is not how that's going to play out. We're not going to get a real value of x back. Okay, so this is kind of the first hint that something was going wrong. But sometimes, like we'll see in a little bit, there's no sign of anything going wrong until you go back in and plug it in, and all of a sudden you're asking for something that's not true. All right. Okay, here's some more that have kind of an extra layer. And I am kind of, at this point, I'm kind of jumping around in the notes packet. I skipped the ones where we had radical equal to radical. I'm going to come back on those, but I'm sure that y'all would know what to do. If 2/3 roots are equal, then whatever's on the inside of those radicals, the radicands, would need to be equal as well. All right. So on the one on the left, you have x plus 5 to the 1/2 power. We got to get rid of this 1/2 power. That's going to it's going to prevent us from solving for x directly. So I'm going to square both sides. So I'm going to say x plus 5, once I square x plus 5 to the 1/2, I'll just get x plus 5, equals x minus 1 squared. But, since y'all have been in this class quite a while, you know that you cannot just say that that's x squared minus 1. We're going to have to set up for FOIL, and that's okay. I'm going to do the distribution. It's going to be x squared minus x minus another x is minus 2x plus 1. Then I'm going to subtract x and I'm going to subtract 5 because I know that if I want to solve this second degree polynomial, I need to set it equal to 0. Okay, minus 2x minus another x, minus 1, or plus 1 minus 5 would be minus 4. And then what do you know? This thing is factored. Right, this would lead us to believe that x was either equal to 4 or maybe it was equal to negative 1. But I know I need to check these answers, so I'll see what happens when we come back. Okay, when I plug in 4, I've got 9 to the 1/2 equals 4 minus 1 is 3. Is that true? Yes, 9 to the 1/2 is 3 because the 1/2 power is the square root. Okay, then when I plug in x equals negative 1, negative 1 plus 5 is 4. 4 to the 1/2 equals negative 1 minus 1 is negative 2. No, it is not. And so when we say, the square root of 4 or 4 to the 1/2, we mean the positive square root. We're not talking the equations to, or the solutions to the equation x squared equals 4. That's to the negative 2. But 4 to the 1/2, or the square root of 4, that's positive 2. This is no. This is an extraneous solution. I'm going to strike through that one and just say x equals 4 is the only solution. Right? The one on the right is another good one, good for our practice. I'm going to pause the video. So if you're watching at home, you're going to want to pause yourself because the answer is about to pop up. All right, there you go. So I've gotten x equals 9 and x equals 4 after doing all the algebra. And now I'm going to check my solutions. Okay, I'm going to plug in x equals 9. I've got 27 minus 11 is 16. I'm not sure why I was having such a hard time with that. Is the square root of 16 equal to 9 minus 5? Yes. Good. Okay. So I guess when I said the square root of 16, I mean the positive square root of 16. Okay, but I say 4 times 3 is 12 minus 11 is 1. Is the positive square root of 1 equal to 4 minus 5? No, the positive square root of 5 is positive. So this one's out. All right, this next one's not on the packet either, but it's going to use that factoring technique that we kind of tried out last time. So I figured might as well do it at least once today. What I'm going to do is I'm going to factor out an x to the 1/2. Okay, it's the only thing I see in common. So I've got x to the 1/2, and I'm going to be left with just 2, because you would multiply x to the 1/2 by 2 to get x to the 1/2, plus 5 times x to the, and remember, this is where we're going to reduce the power by 1/2, because really what we're doing is we're dividing 5x to the 3/2 by x to the 1/2. So we're reducing the power by 1/2. 3/2 minus 1/2 is 2/2. So that's just 5x to the first part equals 0. Now, if these two things are multiplying together to equal 0, either x to the 1/2 equals 0, or 2 plus 5x equals 0. All right, well, this is the square root of x equaling 0. That only happens when x is 0. You can take the square root of 0. Because you think, is there a number that if I square it, I get 0? Yes, if you square 0, you get 0. So 0 is the square root of 0. This one I'm going to solve for x, and x is negative 2/5. And now, since I did not square both sides, I don't need to worry about extraneous solutions. These are both going to be solutions to the equation. Okay, I've got a few more for us. This one's from back into the packet. This is where we had cube root equals cube root. Well, if the cube roots are equal, then the things that we were taking the cube root of, they're going to need to be equal as well, for sure. Okay, so it's going to work out just the way you expect. Okay, I've got x squared minus 4x minus 4 equaling negative 3x plus 2. And you can look at this as cubing both sides of the equation, or just kind of a little bit of sense about numbers. What I'm going to do is I'm going to set it equal to 0 so I can factor, hopefully. Adding 3, subtracting 2, that's 0. This is factorable. X equals 3, x equals negative 2. Since I did not square both sides, I do not need to check. All right, and then here's one that was, I don't know, the numbers looked bad on these, so I'm going to save the one to the right of this one on the packet for a practice problem before the quiz next time, but this one looked kind of bad, so I figured we could do this one. I'm going to try to isolate the radical, or the thing with the fraction exponent, by subtracting 3 x's. Okay, I'm subtracting 3x from 4x, and I'm left with 1x. I take both sides to the 4th power. I get 2x to the 4 minus 81 equals x to the 4th. So I'm going to subtract x to the 4th, kind of combine like terms, and I've got x to the 4 minus 81 equaling 0. Anywhere. Okay, and then this one you could factor, and you'd get both answers. You could do difference of squares 2 times, but I'm going to actually just try to solve for this one directly. X to the 4 equals 81. I'm going to take the 4th root of both sides. Now, when you take the 4th root of both sides, you're going to have to consider the negative as well. So x could also be the negative 4th root of 81. Actually, calculating a 4th root, you can take the square root and then take the square root of that. So the square root of 81 is 9. Square root of 9 is 3. Right? But since I took both sides of the equation to the 4th power, it's kind of like squaring both sides, right? I squared them twice. Take it to an even power, you got to check those solutions. Okay? So I'm going to check over here because I didn't leave myself enough room. All right, when x is 3, I've got 3 to the 4 is 81. 2 times 81 minus 81 is just 1 times 81. Plus 9 equals 12. Okay, 81 to the 1/4 is 3, plus 9 does equal 12. Okay, you plug in negative 3. Okay, well, when you take it to the 4th power, it's going to end up the same. But minus 9 equals 4x is negative 12. Okay, you go and you take 81 to the 1/4 power. That's 3. That's like saying 3 minus 9 equals negative 12. No. Okay, this is an extraneous solution. We're going to not consider that. All right, and the last example I got for you is one where we're just going to solve for a variable. A equals p times the square root of 1 plus r. Solve for r. All right, well, we can do that. This is just get r by itself. So, really the first thing in the way is this multiplication by p. So if I'm multiplying by p, to get rid of that, I'm going to need to divide both sides by p. So a divided by p is equal to the square root of 1 plus r. Okay. The next thing in the way is the square root. So I think about what's the inverse operation of square root. That's squaring. So I'm going to square both sides. A over p squared equals 1 plus r. And then if I want to solve for r, I just need to subtract 1 from both sides. So r would equal a over p squared minus 1. Now, you could also write this. You could actually square the a and the p, right? Because a over p times a over p is a squared over p squared. However you like. And that's, I think, going to be all for today.